So community structure. What do I mean by this? This is when we look at all of the organisms in an area and we're trying to understand the community, how does that come to be? And a lot of times there is a process to it. For a few lectures, we've been mentioning disturbance and how disturbance can influence populations and how that can influence interactions. Now, let's take it to the next step. And when we look at community structure, a lot of the conversation and the studies begin at disturbance. So we can summarize that the pattern is going to have successional change. And this is a gradual increase or shift between the plants and animals that are present in a community. And a lot of times this ends up forming a climax community. Most of the communities we observe on a daily basis are going to be your climax community. Or think of when you go walk through a forest, typically what you see then is your climax community. That community will change over time until what we see. Early on, we would have expected less diversity because it's that time lag of how long it takes for an organism to find this new available habitat and colonize it. So with that, in the early stages of succession and development of this climax community, you would have fewer species, and then ideally what you're seeing is the saturation in that climax community, that the most amount of species that area can support is there. What we can see with areas such as Glacier Bay, we have a lot of history for this area. We can see how that species richness increases over time, and that it's not a uniform increase. And just because a species was there in the early stages doesn't mean that it's going to be there later, nor does it mean that it's going to continue to grow and have a more abundant population. So Glacier Bay has a rich history, and it allowed us to see that differences, and we'll revisit it in a little bit. So some other examples of succession would be looking at a temperate forest and seeing what is not just the first ones to arrive, or our primary successors, but the secondary successors. What do we see next? And many times you could say that this is going to be when hardier species like a woody tree would increase during this second wave of colonization. Then, once you end up with those trees, you would end up with the organisms that support it. And we've covered that at length. So just let your imagination go on now what the following colonizers are for this community. We see similar patterns in streams. So when we have flash floods in a stream system, it can remove a lot of the organisms that were previously there. So what you'll start to see is this change in diversity as organisms recolonize. And remember, we were talking about some of the mechanisms that an organism can move upstream or maintain where it is. So all of those come into play here as that population strives to persist through time, and part of that is colonizing this new area. Now, what's an interesting element is when we talk about ecology, we do say that a species interactions with other organisms and the environment. So that other piece of what we're talking about with ecology, and I mentioned it in the context of nutrients, think of when we did the nitrate cycling through an ecosystem, or our aquaponics and hydroponics system. Here, what we're also able to see is that with disturbance and with the subsequent succession and colonization patterns, we see changes in how the nutrients are moving and the richness of different nutrients in a system. So we can look again back to Glacier Bay and see that through the history that we have increase of pioneer communities over time. And with that increase of species, there was an increase in organic content. You have more living things there. You have moisture, so think of when we were talking about the root structure and how the roots help a plant acquire and retain moisture, nitrogen content. All of those elements increased. And we can see through here in these bar graphs that organic matter, moisture, and nitrogen dramatically increased. So we have our pioneer species to our more hardwood spruce. And once we had spruces present, you can see that all of those metrics of the ecosystem increased. Then we can look at things like bulk density, the pH, and phosphorus, other elements of the ecosystem decreased. And this is as those organisms started using it and creating a stable environment, you would see some of these other elements decrease. Now, not everywhere is as rich in data as Glacier Bay, but we do have areas like the Hawaiian Islands that we get some history, specifically with the tectonic plate shifting and lava flows. We have overall developed these ideas from a rich history of observations, and a lot of what we can see in these patterns comes to that basic ecology, recognizing there was a disturbance or a change in an ecosystem and observing how that ecosystem sort of righted the balance so that it was a healthy community and equally balanced functioning. One of the things that we unfortunately realized when we were the strongest cause in some of these disturbances was with logging. Logging was initially a clear cutting, going through a mountainside and just razing the whole thing. When that was being done, we saw a lot of those nutrients just being exported out of the system. So this had a double hit where our terrestrial environment didn't have the nutrients it needed, nor the moisture in the soil, but everything was getting washed abundantly into the streams. So we had two levels of what was happening. And with trying to understand the balance, one of those big manipulation studies was done where they prevented the regrowth and measured how much this flux or this exit was, and if just replanting or allowing that vegetation to come back would help. It helped some, but it had to work over time. So we can see that dramatically without these plants in place, we had a vast amount of loss in biomass and nutrients, but through the colonization and the succession, eventually those levels built up again. Now, that biomass, I say it's self-explanatory because you can think of the organisms that are recruiting in to the area, but there are some ways of breaking down of how the biomass actually accumulates. So using a forest as our example, we have in the first stage, you have a lot of loss of nutrients and biomass, so that's going to be a lot of reorganization is what that stage is called. And then we're going to go to aggregation. So now we're 100 years into this process, and now we're starting to accumulate this biomass. Then there will be a transition period and that'll decline from the most possible that it can support in this area of biomass to more of a steady state. And with a steady state, you can see this ebb and flux pattern of biomass shifting around the mean. So you go from this incredibly low reorganization to building up the biomass so much to eventually having a steady state. That steady state is what contributes to what we know as the climax community. So we'll go into that soon. So that's generally the process of what we see with succession and the response to disturbances. But now there are some nuances to the organization and the community and how it develops. So it first needs that space. So when we're talking about succession, there is the assumption of disturbance. And so you're going to have some space created. And how those early colonizers manage the rest of this process can be brought into 3 different paths. So we can have that the space is available, we have these early successors, and then it can go into facilitation, tolerance, and inhibition. All of these different paths, though, have their own climax community, and this is cyclical. So what you end up is, as most commonly seen, is your climax community. However, disturbances happen, and you can think of looking and walking through a forest, you see the climax community everywhere, but there may be that old tree that falls over, or a lightning strike on a tree that causes it to fall. In that disturbance, you have now opened up the canopy to a lot of sunlight, and you can see these successionary patterns start again in that area. So what do I mean by facilitation? So sometimes the area created for this process of colonization is not suitable for every organism. Our pioneer species have adapted, whether they are early to the scene or have a really good mechanism to penetrating hard or very tough environments. So those pioneer species can facilitate others to colonize by manipulating the environment, by shifting it so that the nutrients that were possibly hard for it to acquire are much more accessible to a subsequent organism. You can also see that sometimes it's not as easy to germinate or to get your roots in, or the conditions just aren't favorable. The pioneer species can loosen up the soil for other plants or create a secondary substrate that other organisms can colonize on or utilize. Tolerance strikes the in-between, where it's not necessarily manipulating the environment to promote the colonization of other organisms. It is merely present. Now, its presence could indirectly be supporting future colonization, but it's not doing anything actively that's facilitating another organism to come or preventing it. So when a pioneer species does prevent another organism from colonizing, we're going to call that inhibition. We see this in our species interactions. Oftentimes, for benthic organisms, you see this inhibition is also a form of competition. For our successionary patterns, this inhibition could be taking over all of the space rapidly, so nothing else can settle. It can also be putting in a chemical into the environment that deters other organisms from colonizing. We were talking about the intertidal and using these boulders as examples of disturbance. Well, Sousa uses these boulders and took under different disturbance regimes and looked at what was the community and where did the most biodiversity or climax community appear. So really a manipulative but really cool study to see that direct connection between a potential climax community and the frequency of disturbance that can happen. What he ended up seeing is that early successional species didn't survive really well. So they got in there and they set the tone, but as other organisms came in, they did better. These specific ones were more vulnerable to predation on the earlier side, but the later ones were not as vulnerable. You also can see examples of facilitation using his work, where the boulders had first a macroalgae growing on the surface, and that created an area for a seagrass seed to hook in and take root and develop. So that surfgrass seed would not have been able to colonize without the presence of the macroalgae first. We can also see these successional patterns when we have old agricultural fields shifting back and becoming more of the wild land that they were before agriculture. You do see early on inhibition, like there's a lag to once that agricultural land is no longer managed, but then from that point on you'll see facilitation, and that the community will quickly develop. Glacier Bay, we have an interesting balance here. So in the history of Glacier Bay, you can see that through the stages, it takes a while for spruce trees to establish themselves. Early on, they're inhibited, so they just can't survive in the way that the environment is initially. But as the stages go through, it can grow. So the germination, or the seedling progressing, is still inhibited, but if it actually can take, it will grow. And then eventually, as there are more spruce available in the community, that seed can germinate better and grow, but not as well. So now you're getting all of the adult competition on the growth and on the overall survival of adults. So interesting dynamic when we see what's happening in Glacier Bay, with at least looking as the spruce tree as an indicator of our climax species. So what we have are some different ways of describing what's happening as far as a community and its response to disturbance. So you can have a stable community, or these climax communities that have no change, no dramatic changes in the species present. Then you can have resistance, where if a disturbance was to come through, be a hurricane maybe, that community is resistant to that disturbance. So it would take something much more extreme to change it. And then you can have resilience. Now, resilience is an interesting idea and evolutionary concept, because resilience is not putting up a wall, not being resistant to that disturbance, but taking in and absorbing that disturbance and being able to recover from it. So we end up with sometimes an organism choosing the trade-off between resistance and resilience. I know this from the sponge community, where are you going to have a growth form for the species that can take the heavy waves of a hurricane coming on shore and not move and be resistant to it? So no matter how much the waves come through, it's going to just hold its ground. But if it's bad enough, that individual has less likely the ability to reattach or to survive if it does end up succumbing to the disturbance. On the other side for this trade-off is the resiliency. So can this sponge growth form be flexible enough to go with the waves, but when it gets bad, break off and eventually have the ability to reattach? So what you see with the resiliency is that in a snapshot moment, the population may go down. You may lose individuals, but after time to give those individuals to recover, to reattach to the reef, they've now used it as a mechanism of reproduction, and that population has grown. So there's different levels within that scale, but it's a very interesting question about this trade-off of resistance and resilience. So we have an example from park grass looking at fertilizer and how that can influence our communities if you add extra nutrients in. But what we end up seeing is the variability can be a measure of the stability. So how much is there a changeover, as well as the composition. We can also then go to another study where the community can be stable, but the populations within this community can shift a lot. So within our grasses, there's a variation of what we define as stability. We can also look to desert stream stability. And in this case, you have the connection between surface water and groundwater, and it can cause some really devastating impacts when there's flooding. But there are this potential of having a area where there's a buffer and there's some zones of this stability, then there can be also this balance between where you have recovery. And in this case, in the upwelling areas where there was higher nitrate, you had the faster recovery after disturbance. So there's a lot of elements that go into where and when a community responds to a disturbance event. Now, one of the greatest results of understanding succession is in the context of restoration. So we can look to these patterns and understanding the pioneers and who comes next in these successionary stages to know, how do we restore a site? If it was our own disturbance event and we're trying to restore it, or something like Superstorm Sandy that came through and had a lot of damaging effects on Jamaica Bay. Now, we are trying to expedite that successionary pattern. So to be able to expedite and sort of manipulate what can happen in a community, we have to know what are the acceptable levels for biodiversity, the structure of the physically, and the function of the ecosystem. Now, one example I know in Jamaica Bay is West Pond. West Pond during Sandy lost one of the walls of the pond. The pond was freshwater, but in this blowout event, there are now saltwater coming in. So here we have a dramatic change to the physical structure. So restoration of efforts have repaired that physical structure and have planted some early grasses to hold the new beach in place. But it's only now with time that with rainfall and other precipitation events that we can have an influx of fresh water. And that over time, West Pond will again be a freshwater source, not a saltwater from when the wall was breached. There are other examples of different mines. Mining often creates disturbance events that we need to restore, decrease the chemicals or the byproducts of mining, to also these landslide events that we have. There are some that have been in Puerto Rico, some up in Washington. So our efforts as far as restoration are to try and reestablish the community that was there pre our mining activity, or protect our own communities, especially when there's these landslide events. How can we help that ecosystem be more robust and protect our property at the same time? An interesting element to show some time is that when we have logging roads, those often get really compacted and you have to work to restore them. And after all of this effort that was done, you can see that in about 10 years, that logging road can be indistinguishable. Like, it'll look the same as soil from other places in that region. So I've given you a couple examples of restoration. There's quite a few in Jamaica Bay in response to Sandy and in response to time in our development. Another one is creating salt marsh islands. And we have learned that through time, you can't just put dirt down and expect it to stay there and create an island. What we do now as part of the restoration effort as a community is that we know that it needs the grasses. So one of the early pioneers is to get to a salt marsh are the grasses. And when we are doing restoration activity, yeah, we'll build up the sediment a bit, but we'll also bring in adult grasses so that the root system is already present and those roots will hold on to the sediment that's there. And the blades of grass will slow down the water enough to capture more sediment. So as this process continues, the island ideally grows and you'll get the recruitment of crabs and snails and then birds and so on. And so understanding the natural processes that happen in areas like Jamaica Bay, we can try to restore it to what was once a state that we knew was better. So looking at the abundance of salt marsh has decreased in Jamaica Bay. So our efforts are trying to improve that. And by understanding the succession patterns, we're able to be more successful in it. So I'll leave you thinking about Jamaica Bay and some of the other examples we have for restoration or other successionary patterns. And we'll also pick up here next class.